Let's talk about biofuels. Specifically, in what ways might their production and use contribute to climate change? Do they really help?
There are many different production methods for many different biofuels, all of which have unique effects on the environment. Since biofuels are such a broad topic, for this video we're going to focus on bioethanol and biodiesel. Why those two? Well, they are simply the most common biofuels in use today. In 2013, the USA and Brazil produced roughly 80 billion liters of ethanol, while the rest of the world produced about 25 billion. The next most common biofuel, biodiesel, is mostly produced in the EU, which made roughly 11 billion liters in 2013, while the rest of the world made 15 billion liters. Other biofuels aren't used nearly as much as these two, but more on that later. Anyways, how do the production and use of bioethanol and biodiesel contribute to climate change? First, let's discuss the production of bioethanol. It is produced from food crops like corn or sugarcane, or non-food crops, or more specifically, the cellulose that's found in non-food crops such as straw wheat, switchgrass, bagasse, and other agricultural waste. After preparation, the glucose from the food crops or broken down cellulose is fermented using yeast, producing ethanol and some other byproducts.
Biodiesel, on the other hand, comes from fats and oils, or more specifically, the fatty acid chains in the triglycerides which make up the fats and oils. An alcohol, usually methane, is introduced along with a catalyst to break away fatty acid chains from the triglyceride, forming biodiesel or long-chain esters. Glycerol, another component of triglycerides, is a byproduct of this chemical reaction. This process used to produce biodiesel is called transesterification. Now for uses. Ethanol is used as a gasoline additive, but is the main fuel source for select modified vehicles, while biodiesel is blended freely with petrodiesel, but may fuel entire vehicles depending on how biodiesel compatible said vehicle is. For the most part, while ethanol and biodiesel definitely have lower carbon emissions than fossil fuels, the production and use of these biofuels still fail to help benefit climate change. Here's why.
Earlier, it was mentioned that ethanol can be produced both from food crops and cellulose. However, the lack of research and development in cellulosic ethanol means that the enzyme technology required to transform cellulose into glucose for ethanol is expensive. According to the International Renewable Energy Agency, a cellulosic ethanol plant costs more than 3 times as much as a corn-based ethanol plant. Since it is almost always less expensive to use petroleum instead of ethanol already, cellulosic plants are rare and not as economically viable as food crop ethanol plants, despite the fact that, according to the US Department of Energy, the use of cellulosic ethanol could reduce greenhouse gas emissions by 86% compared to gasoline production and use, which is much more than the 19% average reduction from corn-based ethanol. Still, ethanol is not as efficient as gasoline and only possesses around 2/3 of the energy the same amount of gasoline carries. Furthermore, ethanol cannot be transported through pipelines over long distances like gasoline because it can corrode pipes and is hygroscopic, meaning it absorbs water vapor from the atmosphere. This is an issue because water-alcohol mixtures cannot mix properly with gasoline, and vehicular transportation causes additional carbon emissions. However, regardless of whatever plant material ethanol is made from, there exists some form of CO2 offset, because the plants capture CO2 during their growth. This CO2 return contrasts the CO2 addition that is caused by digging up and burning fossil fuels. Despite this, there is also evidence that the few nitrous oxide emissions caused by fertilizer from actually growing the food crops to make ethanol could actually cause the same or a greater amount of global warming, because nitrous oxide has a global warming potential per 100 years in the atmosphere that is 300 times greater than CO2. Global warming potential is the amount of heat any greenhouse gas absorbs in the atmosphere as a multiple to the amount of heat CO2 absorbs. For this reason, carbon dioxide's global warming potential is 1. Nitrous oxide, on the other hand, has a global warming potential of 296. This is another point to keep in mind when considering the sustainability of cellulosic ethanol versus its economic viability, since making the ethanol from cellulose wouldn't require the growth of crops, eliminating the nitrous oxide emissions. In summary, the use and production of ethanol does, generally, have lower carbon emissions compared to the use and production of gasoline, but carbon emissions from the most common types of ethanol, like corn-based ethanol, are only barely less than gasoline emissions, and may also emit an even more potent greenhouse gas. At the same time, more sustainable ways to produce ethanol, like from cellulose, are rarely used due to their cost.
Other than ethanol, there is also biodiesel. In regards to safety when handling and transporting the fuel, it is considerably less flammable compared to regular diesel. But of course, biodiesel has its downsides, such being that it is harder to use in colder conditions due to its high pour point, which is the lowest temperature it can be pumped at. This is with biodiesel having a pour point of about 0 degrees Celsius compared to petrodiesel with -40 to -34 degrees Celsius. But exact temperatures can vary depending on biodiesel percentage and what feedstock was used to produce it. Also, similarly to ethanol, crops specifically grown for their oil to be made into biodiesel, like rapeseed, contribute to NTO emissions due to the fertilizer they are grown with, and that bringing the raw materials to refineries usually requires vehicles which emit CO2. This brings into question if biodiesel even has a positive impact on climate change at all.